Welcome everybody, it's 1:35. That is the start time for this session. I am going to switch over to slides here in a minute. I see some people coming in the room. I'm gonna go quickly because these are only 20-minute blocks. I'm gonna show my face first just to say hello. My name is Ben Cody. I am a civil engineer with Aero Aggregates. I work out of a home office in Connecticut. I do trapeze back there on my inversion table. I do some podcasting, other social media stuff, but I'm here today with you guys on a Friday afternoon to talk about foam glass aggregate. First of all, thanks for spending a little bit of time on a Friday with me. I appreciate your attention. So I am going to share screen. Well, first I'm going to play. That is the entry slide, which is not of much information. That is of more information. A picture is worth 1,000 words, right? So this is what we're talking about today, foam glass aggregate. You can see a scale on the screen there. It's about anywhere from about a ½ inch down up to about 2.5 inches in size. So the particles themselves are pretty uniform. It's a manufactured product, so this is not a quarried stone. This is a synthetic aggregate, as I like to call it. This is an aggregate that's made out of recycled material. So from a standpoint of sustainability, it's a really neat application for recycled glass, which is going to be thrown away anyway. We're going to talk about that here in a minute. I'll give you some quick background on what lightweight fill is. Anybody who's not familiar with lightweight fill, these are just materials that are lighter than standard materials. So soil and rock have a typical unit weight, usually up around 100 pounds per cubic foot. So man, though, has gotten creative over time. We have some, old methods like wood chips, which are down around 25 or so pounds per cubic foot, so about a quarter of that weight. We have some newish as the Industrial Revolution came on board, things with petroleum-based products, right? So you have waste tires, you have geofoam, which is expanded polystyrene. That's just the trade name here in the geotechnical world. Foam concrete. Concrete's certainly nothing new, but foaming it is fairly new as far as adding additives to it. So, adding a man-made touch, if you will, to old types of materials makes them much more lightweight. So what's different about this material is, first of all, it's made from 100% recycled content. So, I think concrete, they can add additives to concrete to make it more lightweight. There's not a whole lot you can do to geofoam or even shale, which is a quarried rock, to make it a recycled product. You can reuse it maybe from job to job, but this is a true recycled product from its inception. What's unique about it is that it's mostly air, right? So you can see a lot of air pockets there on the surface. Those air pockets exist throughout the structure. They're not just on the surface. So most of the structure itself is air. The rest of it is glass, and it's glass that has been ground down to about 50 microns. It's then added with an additive, put through a very hot oven and baked so that the foaming agent and the foaming action occurs. Got a lot of great characteristics we'll talk about briefly here. First of all, it's lightweight. It's about 15 pounds a cubic foot, so much lighter than traditional materials. It's a good insulator. So for this market, for passive homes, this is a replacement for subslab insulation, for foam board. This is all used around the foundation, right? Obviously, you could use this within the building. For instance, you can crush this up and put this into cinder blocks for fire-rated type walls, fire-rated and lightweight cinder blocks. In the case I'm talking about, I'm a geotechnical engineer by trade. This is all subgrade, below grade applications. Okay, so we're talking about insulation from the ground, insulating the building from the ground, insulating the foundation itself from heat loss and changes. So this is a nice niche product for this particular group of people because you guys are trying to use sustainable materials anyway and something that's more energy efficient. So this is going to help achieve a couple of those things in tandem. So it's made in America. All of our glass is locally sourced in and around Philadelphia, Pennsylvania, which is where our first and main facility is. We have 3 ovens running there right now. What you're looking at outside of our plant is about 100,000 cubic yards of foam glass. We produce the largest amount of foam glass in the North American continent. We produce about 30,000 yards per kiln per year. So we make a lot of foam glass. We just opened new plants down in Florida. We have plants coming in New England, luckily for what I do in New England sometime soon. So inside the building, this is what it looks like. You have the glass colored. Those pieces look very clean. The glass that we get is very dirty. We get it from single stream recycling, third-party sources. So we're getting glass that's mixed with wrappers, bottle caps, things like that. We have to process it, but we get it for free because otherwise these landfills are throwing it away. Because in order to make recycled glass, you have to use glass pieces of the same color. So to make a clear glass bottle, you have clear recycled glass. By the time it goes through single stream recycling, it's all broken up. The optical sorters cannot detect the smaller pieces below a 3/8 of an inch. So it goes into a waste pile that they then have to throw away. So we take that material essentially for free, which is pretty nice, right? So we have raw material that's free, keeps our costs down. We have the glass milling. We mill it down to a powder. It looks like basically flour when we're done with it. We mix it, and the average color, so you see a bunch of different color glass. We don't need to color sort. By the time you average that out and grind it down, it's basically a light gray or a whitish color. And then by the time we add a little bit of the black 2% of the foaming agent, that's what makes it this cool light gray color. So it looks a lot like rock. Okay, so once it gets powderized, it gets put into a conveyor belt about 7 or 8 feet wide, and it goes through a very long oven. This oven is very, very top secret. Europeans perfected this over 30 years, so a lot of their technology is adopted from Germany and Scandinavia. It's a variable heat profile, but basically all we're doing is getting that chemical reaction to help occur within the powder. So here we have, oh, yep, I'm clicking the wrong screen. Okay, so there's the yard, which I talked about 2 minutes ago. There's the plant. So to the left is the glass, which is the glass cullet that is all different color. I'm glad to see somebody listening. That's good. Thank you. And then, so once that gets mixed up, it turns into a light gray color. And then the mill operation is to the right. So the milling occurs there to basically turn that into a powder that we can put into the oven. There is the oven, very big, large building. This is the first one that was online. We now have 3 within this building. So we need a very large square footage because the oven is very, very big. So we are housed within an old Civil War era rifle factory. So it's a reuse of a brownfield site, which is also pretty cool. It's not a new facility. So this here is what it looks like coming off the line. It's kind of monotoned. It's not usually this gray, but it is made from 100% recycled material. So it's basically 90. This is a misnomer. It's 98. It's 100%-ish. It's 98% recycled glass. But if you add the 2 in, it's 90% glass and then 2% of the foaming agent is what it comes down to. So the mixture, it's very, very hot. Basically, the powder melts. So it's basically near melting the glass. We want to keep some of the glass structure because that's what gives the material some strength. I'll talk about the different types of foam glass in a minute because how it goes into the oven is very key on the strength afterwards. Okay, so the process then creates the bubbles. So there's a foaming action where the bubbles are created, the glass is softened, and then it cools. And as it comes down the line and cools, it goes from about 1100 degrees Celsius, 1500 degrees Celsius. I can't tell you which one, but it comes down the line and breaks because as it thermally goes back to room temperature, it just has a lot of thermal contraction happening and it breaks apart as it's cooling. The layer cake thickness you see there is about 60 to 70 millimeters. Again, I can tell you which one, but it's the right thickness based on our heat profile to completely get depth penetration as it goes through the oven. There are the pieces as they come up. That's it, and that's basically how they get delivered. So as they break up there, those are the piece sizes. You'll have a little bit of breakup during handling and transit, but very little. So that's how it basically looks like. Again, it's anywhere from about a half an inch to 2.5 inches in size, typically. We can crush it. We have to be very careful because it's obviously very lightweight. So we can't go crush it with standard material or standard equipment. Okay, I think I'm advancing the slides right. And I've got 11 minutes. Okay. I'll have to speed up a little bit. We're good. So I mentioned how it goes into the oven will dictate what comes out of the oven. Makes sense. There's different types of foam glass. So like concrete, like any other material, soil, steel, whatever, there's different grades of this material, right? So how you mix it up, the chemical and the powders and things you add before it will dictate what it looks like on the backside. So it can be closed cell, which is what we make and typically make. Closed cell can come in 2 different types. I'll talk about those in a minute. So closed cell is basically the air bubbles on the outside are not connected to the ones on the inside. Open cell is the bubbles on the outside are connected to the ones on the inside, meaning water can pass through it pretty readily. Not right through it, but. So open cell is a unique product. So you think about water retention and soil and things like that. When you blend this material, use it on roof applications, it's very unique. So we have another market sector that just deals with blue roofs, green roofs, that stuff. There's a consumer brand we have called Growstone that is a crushed material. It's more used for big box stores because it's a lighter bag. so people can have this material and carry it out of the store, not break their backs, which is cool. So agriculture too, again, you can do it as a soil amendment. It's great for soil water retention and that interaction between the plants and the soil. Okay, so then the kind that we typically make and we see used, at least on the transportation side of things, I understand the people we're talking with now. I present this to you guys because in reality, you guys can use both, because the main application that passive home builders are going to use this material for is for insulation. This material insulates very well, but there are differences, okay? So for the wet process and dry process material, you'll see the ingredient mix there on the screen, and it's pretty self-explanatory. The dry process material we make is no wet product. There's no water, no slurry or anything. There is a wet process that makes a different foam glass. You can see it makes it a little darker in color. It looks kind of a little bit more like charcoal. And it doesn't change anything as far as the insulation, because what we're doing is still creating dry cell material that has bubbles not connected, right? So that's what keeps it interlocking. So the insulation properties are the same. What's different though is that the strength properties are different enough where it matters in the unique application. So dry bulk density, so from a weight perspective, they're very similar. You know, you have 10 pounds a cubic foot, 14 pounds a cubic foot. You know, percentage wise, that's a lot, but it's still very, very lightweight material. What happens though with the wet material is that because you're adding water to the matrix, you're inherently making the material softer from a compression standpoint, right? So it can't take as much load. Again, it doesn't matter from an insulation perspective, because you guys are typically using this to insulate the building subgrade. But in the transportation markets, other things where this is used below roadways, below behind bridges, retaining walls, things like that, major infrastructure that needs a bit more robustness with the cells, with the intercell structure, the dry process material is significantly stronger, like 3 times stronger. So those are the typical values as far as compressive strengths. That's the test that we run in our lab and the test that's run standard in Europe. There's also different tests they run in Europe. This one isn't quite as applicable for foam glass because it's really meant for boards. So you have a big thick section that you're trying to squeeze, which obviously makes no sense for a foam glass particle. But even in that case, the material test, you know, you do the test anyway because it's a standard. And the dry process material is definitely quite a bit stronger. Again, this picture shows a very large scale application for foam glass. Large scale applications are in transportation projects. They're using it for the lightweight material, as not so much for the insulation. They use it because it's a replacement for rock. So for them, rock is heavy on very sensitive soil sites. You don't want a lot of settlement or compression of the soil. So using a lightweight material is advantageous because you're not going to get settlement. In your application, you're just looking probably for insulation. Probably not going to even backfill it like this. These are large scale applications where a dozer is placing it. On small scale applications, it's literally just a plate tamper. It's a plate tamper that you probably already have on site. It's about 220 pounds. You can do 1 foot lifts. So a 1 foot lift, I think I have a slide on this in a minute. A 1 foot lift is about 12 inches of foam glass. So foam glass has an R value of about 1.6 to 1.7. That value does change if it gets wet. If it gets wet, it goes down because water is thermally conductive. So if you have a 1 foot layer of foam glass, you will have an R value of 20. I know I'm throwing a lot of information out. I got 6 minutes left. This is how the material comes in. Also unique part of this is that we can ship a lot of material with not a lot of trucks. That is a 53-foot trailer. The 53-foot trailer holds about 80 to 90 yards at a time. Compare that to a triaxle truck holding soil or rock that only holds about 20 yards-ish, depending on the size of the trailer. I mean, you obviously hold more, a bigger trailer, but you know, depending on the weight of the material, you don't want to, you know, get stopped by the state police. So I'll call it 20 yards of material. And we get over almost 100 yards, right? So just think of that scale. We can also bag it. We can put it on flatbeds or intermodal, you know, and ship it via wherever in bags and containers. So those can go rail. They can go over the ocean. They can go wherever. So it's a very portable material because it's lightweight, right? So it's not taking a lot of, its carbon footprint is very low because it's not taking a lot of energy to get it from where we make it to where the end use is, okay? This is a gradation. I talked about that before. So it's anywhere from about 2.5 inches to a ½ inch in size. This is the thermal conductivity data. So this is just a graph showing when you put foam glass down, how does it insulate the soil? So in Scandinavia, they do use this material just for insulating the soil. So below a roadway, it's unique because you don't get that frost heave effect. But obviously it translates to the building market because this is a great substitute for for foam board. So again, this is also just showing you have a dry value and a wet value. So the dry value is about 1.7 R value per inch. So again, about 12 inches is going to be an R20. And then if you have it wet, if it's wet for whatever reason, it's outside the building footprint, subject to rain, it's going to be about 1.2. Okay, I'm going to show some quick applications. This is more from the structural side. So from just thinking about your foundation wall, right? Foundation walls are designed to hold back loads, you know, typically because it's an open space underneath the building, but they have soil on the other side, so there's going to be pushing. If there's less pushing because the material is not as heavy and it's got a very high friction angle, so this material has the equivalent fluid pressure of about 3 PCF, as opposed to soil, which is anywhere from about 20 to 40, depending on how you shake it. Point being, you can really thin out your concrete. So this is having a system effect now, right? So like, it's not just, oh, this material is an insulator. You can also use it to help reduce your concrete impact, your steel impact, things like that. This was done in Maine even on a bike path. So they were trying to get this lightweight retaining wall to work underneath a bridge. Again, I'm talking about underslab applications. So typically, as a geotechnical engineer, you recommend a capillary break. That's breaking any of the water action coming up from the soil. Basically allows that frost disk to dissipate before it heaves your slab on grade. So again, that's a layer cake system where you have gravel and insulation. This material acts as gravel and insulation because it has the same characteristics as both. It also acts as a potentially a radon collection system. In this case, we did a project on the Cape. The soils are fine. They didn't need any lightweight. They wanted to use it for insulation, but they also had radon on the site. This material has the same gradation as a radon collection system, so you can use this material to convey radon gas as well. 11 East Lenox Street, this is a very large CLT building in Boston that was just constructed. I think it was 6, 7, 8 stories, something like that. Very soft soil conditions. Geotechnical engineer had not only ground improvement below the footings, but a lot of this material underneath the slab. I believe they also took advantage of using it for the insulative impacts. But you can imagine a 6-foot section of foam glass at an R value of 20 per foot. You get 6 feet of that, you're talking an R value 120. I don't think you're going to need much foam board after that. Same thing at St. Albans. So St. Albans Town Hall, this project, beautiful project site right on Lake Champlain. This was a great site. But it's super soft soil. So it's Lake Champlain soils, very silty, very, very soft. They wanted the building elevation up about 4 feet from where it was already. It's going to have some settlement. They were going to put some soil on site and wait for 6 months for the settlement to occur. They didn't have time for that. So they basically removed some soil, put the lightweight fill back, and there was so much stress relief on the site, they were able to get that built pretty quickly. Okay, I got 2 minutes. And again, so I show a lot of big projects. We do a lot of DOT projects, but foam glass is very scalable because we're just shipping by the truck. So if you need 1 or 2,000 trucks of foam glass, it is what it is. It's a unit rate, right? So the unit rate applies to whatever you're buying. The unit rate typically right now is anywhere from about $90 to $100 per cubic foot, because I know people might ask that question. Shipped anywhere in New England, that's where we're typically at. Depends on the quantity, depends on the timing, all kinds of things. But that's generally where I see it right now. That's obviously going up too as the market's going up. I'm seeing trucking and diesel, obviously charges are making that all crazy. Point being, we're very scalable. So this is a house in Connecticut where they put down a foot of foam glass because they needed an R value of 20, and they have a plate compactor there. That's literally all that it takes for plate compacting. That guy's going to go over the surface 4 times, and then he's done, and that's it. So with that, I'm actually a minute early. Look at that. So that's, again, our plant in Philadelphia. This has a lot of great characteristics and applications for potentially your projects in the passive house market. It's a sustainable product. It's 100% made from recycled glass. It's different than really anything on the market in the lightweight industry, and it's going to get rid of hopefully some foam board and maybe even help you out on a soft soil site, which a lot of these passive house markets are, they're going to probably be on soft soil sites anyway, because that's a lot of what's going to be built or left. It's either going to be a reuse site in these urban markets, or it's going to be a soft soil site. So that will help you out as well. So with that, I'm going to leave it open to any questions. I'm not sure if they're going to come through via the chat or stop share. Come through via the chat. Oh, look at that. There's way more people than when I started. If anybody wants to turn cameras on and unmute, I'm not super scary. If not, oh, I see some chat slides advancing. Yep, slides are advancing. The heating source footprint. Not sure what that means. The heating source. Oh, the heating source as far as the kiln and the oven. Yeah, so the kilns, that's the kicker, right? So like we get so much good stuff and it's not perfect, right? So like our plant, Philadelphia, runs on natural gas. There is an impact for that. We have life cycle cost analysis that does all that. Our future plants are going to be actually solar powered, so they're electric. Those still have a footprint, but they're a heck of a lot better than natural gas. So it's not perfect. I think as the European technology gets better, because we don't develop these ovens stateside, we just basically take the European technology like a lot of people do. A lot of this, that's all we're doing a lot in this industry anyway. So we take the European technology and convert it to this market. This market isn't necessarily ready for things of this size that need this much solar power. So right now we're kind of getting by on natural gas. It's not the best way to do it, but we're hoping to change that. R20 per foot, is that 1 foot compacted or 1 point question mark? Yeah, that's 12 inches in place. Good question. It will go down. So to get to 12 inches, you got to put 15 inches loose. The compaction factor is about 20%. That's for dry process. For wet process, it's about 35, 40%. That's the other kicker. Is the softer material, it's going to squish down more. So you have to start probably with 18, 17 inches of wet process material to get to 12. If you use dry process material, it's going to go from 15 to 12. So you have to buy less to get a foot in place. Hopefully that answered your question. So R20 is 12-inch compacted in place in service. Okay, I'm at 1:56. I think that means my time's over. Thank you all for your time on a Friday. I appreciate your attention and your questions. If you have any questions, please reach me. I'm going to put back up the screen real quick if I can. That's my email address, bcody. That's it, bcody@aeroaggregates.com. So BCOTE@aeroaggregates.com. Thanks, everybody. I hope you have a great Friday and a great weekend.